Hello everyone. Today we will be discussing some of the questions related to GATE Excel chemistry. The topic of today is chemical kinetics and chemical equilibrium, and we will try to solve three questions in this topic. So the first question is in your screen, which came in GATE 2019, and this is the question number 6, which carried 2 marks. And the question states for the reaction mechanism 2x going to y. For this step, assume the K equilibrium value to be concentration of y divided by the concentration of x squared, and there is another equation given, reaction given, that is y is converting to p, which in which the rate constant is this small k. Now what they want to ask is what is the rate law for this equation or this reaction y converting to p. So for this, since here we are coming across the chemical kinetic terms like rate law, and so first I want to discuss with you what is the rate of a reaction. So the rate of a reaction means when a product is going formed from the reactant. So then what is the rate of the conversion of this reactant to the product, or when a product is getting converted reverting back to the reactant, then what is the speed at which this chemical reaction proceeds is called as the rate of a reaction. Since I have talked two types, that is from reactant to product or from product to reactant, so as you can see that there are two graphs where the product concentration starts increasing whereas the reagents concentration starts decreasing. From here, if you want to define rate in a mathematical form, then it is given as rate equals to half of the rate concentration or the disappearance of P, which is again equal to the disappearance of Q. Why it is disappearance? Because this reactant are converting into product, thus their concentration is decreasing, whereas the product, that is here the R, the concentration of R is increasing, that is why the rate is equals to appearance of R. So in this formula it is this 1 by the stoichiometric coefficient of that particular entity. Here if it is P, the stoichiometric coefficient is 2, that's why we have divided it with half, then the concentration of the disappearance of P. Whereas for Q it is 1, that's why it is 1 by 1 is 1. So it is simply disappearance of Q. So simply if we want to define rate, it is the change in the concentration of this concentration change divided by the change of time. That is, the change in the concentration per unit time is called as rate, and the unit from this formula we can get is the concentration unit is mole liter inverse, and here the time is in the divided portion, that is that we have to divide it with time, that's why it is second inverse. So the unit is mole liter inverse second inverse. Now another concept which is very important for solving that question is the law of mass action. So law of mass action states that for a reaction, chemical reaction, the equilibrium constant, that is the K equilibrium, is equal to the concentration of the product to the power of its stoichiometric coefficient divided by the product of the concentration of the individual reactant to the power their stoichiometric respective stoichiometric coefficient. So here in this equation you can see that the stoichiometric coefficient of A is small a, whereas the of capital B is small b and capital C is small c. So in that way the K equilibrium value is coming as this, that is the concentration of capital C to the power small c divided by capital A concentration to the power small a and multiplied by concentration of B to the power small b. This is the law of mass action. but we are actually going to see the proportion of the change of these concentrations with respect to the time, and that can be defined by the rate law. So what is the rate law? The rate law, also known as the rate equation for a chemical reaction, is an expression that provides a relationship between the rate of a chemical reaction and the concentrations of the reactants participating in it. Okay, so here the rate is directly proportional to, again, the concentration of the reactant, to the power their stoichiometric coefficient. So for this equation, the rate law will be the rate of formation of this product C, that can be written in a differential form by d dt of concentration of C, which means in a small amount of time where dt, this time, tends to 0, in that time how much change in concentration is occurring in the C is defined by this equation, where it is equal to the k, small k is here the proportionality constant, which is also known as the rate constant, multiplied by its concentration of its reactant to the power of its stoichiometric coefficients. So here we get the basic idea of what is a rate law. Now let us look back to our questions again. So here this is our chemical reaction, that is Y is converting to P, and then what will be the rate law that they have asked to calculate. But here you see that they have also given a K equilibrium value. So here in this equation there is no K equilibrium constant present. So how will we get that? For that they have given another reaction, that is 2x, which is a reversible reaction, and for equilibrium we require a reversible reaction, and here it is K equilibrium value is given as concentration of Y divided by concentration of X square. And what we need to find? We need to find the rate law where this K equilibrium value should be present, because in three options it is present, and we will check also whether this B option is correct or not. Now the solution of that question will be, that is 2x is converting to twice the x is converting into y. This is the first chemical equation that is being given. So now we know that K equilibrium value, that is the equilibrium dissociation constant, from here that this value will be equal to the concentration of the product to the power its stoichiometric coefficient, which is 1 here, so that's why it is only y, divided by this concentration of x to the power its stoichiometric coefficient, which is 2. So its value is coming as y equals to K equilibrium into, when we transpose it, this x square to the left hand side, so the value comes of y, concentration of y comes to be K equilibrium into concentration of x to the power 2. So this is important and we have marked it as 1. Now for the next reaction, where they have said that the Y is converted into P and the rate constant of this reaction is small k. So we know what is the rate law. The rate law is, that is the formation, the rate of formation of P, that is dP by dt, will be equal to small k into small y, the concentration of small y. But here in the B option, which did not contain the K equilibrium value, the equation is not correct, since it has power 2 and also x is there. Now what we did is that here we substituted the value of y from the equation 1. So what we get now is dp dt equals to small k, and in the place of y we get this, that is K equilibrium into the concentration of x to the power 2, which will be your answer, and that is your option D is correct here. For reference, to know more about this rate kinetics as well as equilibrium, I have given two links or two courses. One is rate processes by Dr. M. Haldar of IIT Kharagpur, and also Dr. Amber Jain whose course runs on chemical kinetics and transition state theory in NPTEL. So you can refer to these two NPTEL courses for getting more insights about chemical equilibrium and chemical kinetics. Thank you.